like to, I already mentioned there are the three important model, the CAD, like geometric modeling, computer graphics, and the design analysis tools. And let us start with the geometric modeling part. Quickly, just give the brief of the geometric modeling, and let us I like to change the slide here. Another slide.
Hello.
Just a minute. I just changing the slide actually.
Okay, sir.
Is it visible?
Yeah, sir. Yes, sir.
Okay, the next is geometric modeling, the most important module in any CAD software development point of view, CAD software users point of view. Geometric modeling, this concept is very important. Why? Because geometric modeling plays a crucial role in the overall application of the CAD C tools. Whatever information you will enter through your keyboard and mouse during geometric modeling, that means during 3D modeling, using your software, it will be utilized in a number of downstream applications. So that is why the concept of geometric modeling is very important from the CAD user's point of view. And CAD developer's point of view also it is important because you have to write the equation of the different geometry. So you have to code it. So that is why geometric modeling is also important or much more important those who are CAD developer. But those who are CAD user no need to think about what are the equation inside. They should know how to use that one or how to do geometric model correctly so that that model can be used in many downstream applications. So downstream applications are like design analysis. Design analysis, in order to analyze any mechanical, for example, if you like to carry out the dynamic analysis, so certain thing you have to evaluate of your link. Link geometry might be complex. Centroid calculation is very important. Cross-sectional area, volume, because you have to calculate the mass property and inertia property. And mass property and inertia property is the function of your geometry, or function of your volume, function of your area. So that is why if you like to do some analysis, like kinetic analysis, or say finite element analysis, you have to estimate the mass properties, and for that evaluation of the centroid area volume is very important. If your shape is simple, you can do manually, but if shape is very complex, then you have to use the software because it is a tedious job otherwise. So using the geometric modeling, the mathematics inside, you can easily calculate the area, volume, and all thing using your area integration, the volume integration, all these theories they're inside area integration and the volume integration method. So using that, using the code of that, computer will quickly calculate the mass and inertia property. And that is why during geometric modeling, your model should be correct one, so that you can calculate the correct mass property and inertia property, which is required for your kinetic analysis. You can check interference between the different component in the assembly, so that using the geometric model, you can do the modeling simulation that I mentioned. You can do the finite element analysis, the space analysis, vibration analysis, thermal analysis. So everywhere you need geometric model. So that is why geometric model should be correct enough. Again, another application, downstream application is the drafting, automatic drafting, automatic 2D drawing generation is possible using the 3D model. So if your 3D model is correct, then only you will get the correct 2D drawing. If 3D model is not correct, then your 2D drawing also be incorrect. So that is why correct geometric modeling is very important, because it will be used for the automatic drafting, automatic dimensioning, automatic your sectional view generation. Geometric model is also used in manufacturing. As you know, there are the different manufacturing process, either in CNC or robotic application. If your product geometry is known to you, and another interesting area that the machine will not work without geometric model, that is 3D manufacturing or 3D printing. You already know that additive manufacturing and 3D printing is such a disruptive manufacturing technology, or the cutting edge manufacturing technology, which will work only if you fit the geometric model. Without geometric model, it will not work. Other machine can work based on your 2D drawing and writing GMN code. G and M code, you can also generate the toolpath, but additive manufacturing you need geometric model. So your geometric model is the most fun. Geometric modeling is the very fast step, and it should be correct one. After that, for preparing the bill of material, in order to planning stage, the material requirement planning, your the process planning, everywhere the geometric model is required nowadays, because every process has been automated. So geometric model is required. Similarly, computer inspection and quality control, there also geometric model is required. So from this downstream application, you can realize that geometric model is very important, and it is a very fast type of CAD. So it should be correct one. So geometric model should be correct one, because it is a starting point and it has downstream application. Without the geometric model, the downstream application will not work. So it should be unambiguous representation of your links or of your mechanical components or your object. Now, that I mentioned, it is important that geometric model generated should be as clear, as comprehensive as possible, so that the other modules of the CAD CE system are able to use the information in the most optimal way. So geometric model are broadly classified into two groups: two-dimensional modeling, that 2D modeling, this is generally used for drafting purpose, and the three-dimensional modeling, it is again based on its evolution or its development. It has been classified as the wireframe modeling, surface modeling, and solid modeling. So wireframe modeling means any solid object can be represented by its edge, just like you bend a wire along the edge and you can represent a solid object. That is wireframe modeling. Or any solid object you can represent by its surface. That is called the surface modeling. And the latest one, the solid model, and it has more advantage than the previous two. So that in three-dimensional model, within that the wireframe model, it has a advantage, like advantage means it is the most fundamental one. It doesn't require it's simple, doesn't require so much computer memory and time, and it can be used only for the simple NC toolpath generation. But this one is the fundamental. Still, there is a wireframe modeling technique, wireframe modeling, or wireframe entity is there, because this is the building block of your solid model. So that is why wireframe, you cannot eliminate the wireframe model or wireframe entities. But if you use simply wireframe model technique or wireframe model, then it has a lot of drawback, because you cannot calculate the mass property and inertia property using only the wireframe model. And the interpretation of the wireframe model having many edges are very difficult to visualize properly. So better the surface modeling, where as it is a model is represented by the surfaces like planes, rotated, or the curved surface, or any other synthetic surfaces. So it can visualization point of view, which much better than the wireframe model. But both surface modeling and the wireframe modeling is the core for any solid modeling tools or solid modeling software, because in order to develop the solid model, starting point is your wireframe model or surface model. So what are the advantage of surface model? Surface model of an object is relatively more complete and less ambiguous representation than the wireframe model. Then this method is very much useful in a specific non-analytical surface, that is free-form surface or the sculpture surfaces, such as those used for modeling automobile or the airplane bodies, the turbine blades. And it is application point of view, surface modeling can be utilized for finite element modeling also for toolpath generation. But calculation of the mass property, inertial property should be difficult for the wireframe surface modeling. Next, the things we are using, that is the solid model. It is the more complete representation than the surface model, as well as the information required for the engineering analysis and manufacturing can be obtained with this technique. And it has a lot of advantages. You know that the solid model produces accurate design, it provides the complete 3D definition, it improves the quality of the design, improves the visualization, and has a potential for functional simulation. Now here that different warframe entities are available in your any CAD software, and backside of that is there the full of mathematics. That means it is represented by the mathematical equation. Now if your job is to a CAD user only, then you have to know in a particular software what are the icon is available, and you have to use that particular icon in efficiently so that you can develop any complex object. But if your role is the CAD developer, then backside of the icon you have to know that how you will represent a point, how mathematically you represent the line, arc, circle, conic section. I mean, different way you can represent mathematically, so that in-depth knowledge of mathematics or geometry or the solid geometry is required in this case. Now, wireframe entities are the is called the geometric primitives are broadly classified in two groups. One is the analytical entities or analytical curve, another is the synthetic curves. Analytical curve is basically described by analytical equation. For example, you already know from your mathematics class equation of line, equation of arc, how to represent the point, equation of the circle, equation of the different conic section. There are different types of representation. But synthetic curve is described by set of data points, which is also known as control point, but it is also mathematics inside, but description is based on a set of data points. The different synthetic curves are the cubic spline, Bezier curve, B-spline curve, and there is a concept called the knobs. Now, that synthetic curve is nowadays very much useful. Reason that I will tell now that first you just see the analytical curve. Analytical curve I just mentioned to describe analytical equations such as line, circle, conic. That provide very compact form to represent shape and simplify the computation of the related properties such as area and volume. But your analytical curves are usually not sufficient to meet the today's geometric design requirement of a complex mechanical parts like automobile bodies, airplane wings, propeller blade, bottles. For that design, and see if you can use analytical curve is not as aesthetically beautiful, or sometimes it not. You have to compromise your the shape which is given by through your aerodynamic calculation. So that is why there is a birth of synthetic curves, which is basically described by set of data points or control points. And this provides the designer with a greater flexibility and control of the curve shape by changing the position of the one or more data points. Now, synthetic curve, there is the why synthetic curves in design is required. There are the two occasions. One, knowingly or unknowingly, we all are user of synthetic curves. When you have carried out your lab class in your physics lab, chemistry lab, or engineering mechanics lab, or any engineering lab, fluid mechanics lab, so you have carried out a lot of experiment. Experiment that is independent variables, that is a controllable variable, there are the dependent variables. You control the independent variables, then you measure that output, that is the dependent variable. The data will tabulate. After tabulation of the data, we used to take a piece of graph paper, or nowadays MATLAB or the Excel, whatever maybe software, or in school level you use the graph paper and you plot it, because you have to interpret your result, the data whatever you're getting from the experiment, you have to interpret that. So whether it is increasing, decreasing, how rate of increase, rate of decrease, like that pattern, and that can be do by graphical representation. And whenever you like to plot that one, you might see that whenever you plot the x versus y, graph paper, after plotting the point, after pointing the point, you are passing through a curve by freehand or by means of the device called French curve. You try to fit a smooth curve. So that curve is nothing but your synthetic curves. The curve you're feeding in that experiment, the graph paper, by your free hand or by French curve, it's nothing but a synthetic curve. And that particular curve is described by your data points. And that problem is nothing but the curve fitting problem in respect of your tools like your Excel or the MATLAB. So this is the one occasion where synthetic curve is very much useful, when the curve is represented by a collection of major data points. So this is the one. Another is there are the use of synthetic curves or synthetic surfaces in the reverse engineering application. For example, you have to recreate a sculptured surface of a Godrej, the old, say, 2000, 4000 years old, your sculptured surface is there, you have to reproduce. So which we will do, you just take that particular model, and using the coordinate measuring machine, CMM, either contact type or non-contact type, you measure the data points over the particular surface, that is called the cloud data, and you fit the curves or the synthetic surface through the data which is measured using the your CMM, coordinate measuring machine. So using coordinate measuring machine, you whatever cloud data you are getting, through that you fit the surface, synthetic surface, and you will get the sculpture surface, then may convert it into solid. Then after that, the traditional manufacturing process or additive manufacturing or 3D printing process, you can print it. So that means there is another application of synthetic curve or synthetic surfaces for reverse engineering application. Second one is when an existing curve must change to meet the new design requirement. For example, the body of your car or body of your two-wheeler, you see nowadays the body, the aesthetic outer look of the car, outer look of the bike is aesthetically so beautiful than previous. It is because of the application of the synthetic curves. Previously most of the curve used the analytical curve, but nowadays because of the advancement in the CAD software, they are using the synthetic curve or synthetic surface to give the aesthetically beautiful surface. Can you follow that one, or that time it has been disconnected? I don't know actually in between. So whatever I have explained regarding reverse engineering, that time you are connected or not?
Yes, sir. That time we were connected, sir.
Okay, okay.
Okay.
So the second occasion where the your synthetic curve is very important, when the existing curve must change to meet the new design requirement. For example, the outer surface of automobile, or the yours aesthetically beautiful different type of packaging bottles, or many other things, the aesthetic is now very important. An aesthetically beautiful surface can be, you cannot create aesthetically beautiful surface by using only analytical curve. So it is possible by using synthetic curve as well as the synthetic surface, and that is why synthetic curve and synthetic surface is very important for the nowadays product development. And because of the application of this one, we are getting aesthetically beautiful car nowadays, aesthetically beautiful two-wheeler, like different types of bikes and the different electronics gadget. even household appliances, all nowadays aesthetically beautiful, and it will improve future also. So there are the two way the synthetic carb has been constructed, that is called the synthetic carb construction techniques. One is called the your interpolation method, another one is called the approximation method or approximation technique. In interpolation technique, curve passes through the all the data points, whereas in approximate technique, curve doesn't passes through the all the data point. Rather, it will passes through the few data points, and remaining data point act as a control point. Now, mathematically, synthetic curve represents basically a curve fitting problem to construct a smooth curve. So it basically a curve fitting problem. Now we like to explain with the figure the difference between the interpolation techniques and the approximate techniques. In interpolation technique, curve resulting from that it is passes through all the data points, and curve itself is called interpolate. And the example I have shown here, cubic spline, where P0, P1, P2, P3 to up to P12 are the data points that you got from, say, experiment or from the, say, coordinate measuring machine. Now you feed the smooth curve through all the data points, and the curve or synthetic curve generated by this technique is known as interpolation technique. Approximation techniques, where the curve doesn't pass through the all data points, rather it passes through a few points. For example, here side example, the Bezier curve, where the yellow color curve or the white color curve, which passes through the P0 point and P3 point, remaining 2 point P1 and P2 is act as a control point, which basically controls the shape of the resulting curve. So that method is called the approximation technique. Most often approximation technique are preferred over the interpolation technique in free-form surface design. Free-form surface design means the sculptured surface design. So for that, approximate technique will be preferable than the interpolation technique, because it will add more flexibility and more additional intuitive feel by the approximation technique. Now, CAD developer's point of view, if you see, then that particular synthetic curve or your analytical curve, how it has been represented within the CAD software, what are the mathematics is used, that is important. But it will, the first thing, only thing I emphasize here, the curve can be represented mathematically by many ways. By the non-parametric equation, it may be the explicit form or implicit form, or it may be the parametric equation. Now, the most of the CAD tools are basically use the parametric representation, or all the nowadays all the tools are using the parametric representation of the curve. For example, if you represent a circle, equation of the circle, say if it's the origin at the center of the coordinate system, equation of the circle equal to x square plus y square equal to r square. Same circle, if you represent in a parametric representation, then it will be represented as x equal to r cosine theta and y equal to r sine theta, where theta is the parameter. In this case, I have chosen u is the parameter. So that is the parametric representation of the curve. For any curve, the two way, non-parametric way you can represent, and also parametric way that you know from your mathematics. In CAD software, it is represented by parametric way. That means parametric representation of the curve and surface, synthetic curve and surfaces has been used in the CAD tools, where each point on a curve expressed by a function of a parameter, say u. So u is act as a local coordinate for the point on the curve. So now, what are the advantage of parametric representation of the curve? So parametric geometry can be easily expressed in terms of vector and matrix, which enable the use of simple computation techniques to solve the complex analytical geometry problem, and to check whether a given point lies on a curve or not, and reduces to finding the corresponding u values and checking whether that value lies in the stated u range. So because few more advantages there for parametric representation, and that is why CAD developer adopted the parametric representation. So there are the another concept which is very much required in case of the use of the your synthetic curves or even in analytical curves, blending. So blending is used to construct the composite curves. That blending of the two curves implies the joining of the two curves subjected to satisfaction of continuity condition. Various continuity requirement can be specified at data points to impose various degrees of smoothness of the resulting curve. In order of continuity, now becomes very important when the complex curve is modeled by several curve segments, and that order of continuity, because suppose you like to create a complex curve by joining two or more curves. When you join a two or more curves, at the joining point there should be a continuity. Now what are the different types of continuity? That is there, this is the terminology is called order of continuity. Now order of continuity are classified into three groups: zero order continuity, or mainly used in CAD software, the zero order continuity, first order continuity, second order continuity. Zero order continuity is called C0 continuity, which is position continuous curve. For example, see here I have shown the three curve segment: first, second, third, three curve segment. In between first and second there will be a joining point. At the joining point the coordinate is same. That means the end point of the first segment is a coordinate of the end point of the first segment is same as coordinate of the starting point of the second segment, and so on. So that is why it is position continuous. But if you see the tangent at the joining point, tangent of the first curve is one direction, where the tangent of the second segment of the curve at the same point is different. So it is, that is why it is only position continuous. But if you like to design a first order continuity curve, composite curve, then you have to go for the both should same endpoint position as well as the endpoint tangent for both the curve segments should be same. So this example shown at the joining point, the coordinate is same, at the same time tangent of the both the curve segment at the joining point is remain same. So that is why it is slope continuous curve or C1 continuity curve. Third one is an example, the cubic spline curve is basically first order continuity curve. Second order continuity curve is the curvature continuous. That means for here first order continuity curve means it is position continuous, it is position and the slope both are same for both the curve segment at the joining point. Second order continuity curve A, where it is position is same, that means two end point coordinate is same, tangent is also same, that means slope is same. At the same time center of curvature is also same, both the curve. But in the C1 continuity curve or the first order continuity curve, center of curvature was different. You just see the middle figure, center of curvature of the two curve segment was different. But the last figure you see center of curvature for both the curve segment is same. So that is why second order continuity curve is not only position continuous, it is slope continuous as well as the curvature continuous. An example of the curve designed based on the second order continuity is the B-spline curve. Now from these three figures, if you compare, you can easily say C1 continuous curve is smoother than C0 continuous curve at a joining point, and C2 continuous curve is smoother than C1 continuous curve at the joining point. So you can conclude C0 continuous curve is much more smoother than the C0 as well as the C1 continuous curve. So depending on your requirement of how much smoothness you need in your design of a composite curve, you select the either first order or second order continuity curve. Zero order continuity curve has not that much useful in respect of the our machine design or design. So as you know, the first order continuity curve, here the example synthetic curve, say cubic spline. This is the example of the first order continuity curve. Now cubic spline, the name itself says its degree of the curve is 3 because cubic and it's spline. So the cubic spline, or knowingly or unknowingly, you have used this cubic spline in our engineering drawing class. So, but it is basically in CAD, it is developed or it is constructed by interpolation techniques, and it is parametric representation with a specified order of continuity, the first order continuity. And parametric equation, highest order is the third degree polynomial, highest degree or highest power is the 3 of that particular parameter u. And it is basically what came from the traditional drafting tool called the spline or the French curve. You know, you have used, that is also known as spline, and that is why this curve is known as spline. Why it is cubic? Because the parametric equation having the highest degree is the 3. Now, the parametric equation, if you see, this is the parametric equation of the curve. That means your parametric equation, any point on the curve can be represented by the equation where it is equation is C1 u plus C2 u square plus C3, C naught, naught into u to the power naught plus C1 into u plus C2 into u square plus C3 into u cube. Maximum degree of u is 3. Now u is the parameter, is varying from 0 to 1, and C0, C1, C2 and C3 the polynomial coefficients. And in order to design this particular curve, there the unknowns are your C0, C1, C2, C3. Now, how many boundary conditions you need? Because there are the 4 unknown, you need the 4 boundary condition. That means you need 4 data points to design the cubic spline curve. And that has been shown in the below figure that the 4 points has been shown here to design a cubic spline curve. So after solving this parametric equation, you will get the C0, C1, C2 and C3, and your cubic spline is over. But here 4 boundary condition is required. The 4 boundary condition means 4 data point is required. This is called the simple cubic spline curve. There is another design of the cubic spline curve which is designed by the Hermite. So Hermite cubic spline, again same equation, then 4 boundary conditions required, but boundary condition is different in this case. In this case, boundary condition are, in case of Hermite, 2 endpoint coordinate and the 2 endpoint tangent vector information will be there. So here that it is the Hermite cubic spline is designed by 2 points, but at this 2 point tangent vector information should be known to you. That means ultimately 4 boundary conditions, the coordinate as well as the tangent vector information. Using that you can design the Hermite cubic spline. Next is the Bezier curve. It is based on this design is based on the approximation technique, and it is developed by P. Bezier, which is the designer of the French car that is of the French car company Renault in the year 1962 in his CAD tools called Unisurf. So they defined that this particular curve, and they have used this particular curve to design the outer panel of the several Renault car. And in the name of Bezier, so the curve name is also called the Bezier curve, and it uses the vertices of the Bezier polynomial. That means the data points is P0, P1, P2 and P3. Now you join the data point by the dotted line. That is the Bezier polynomial, but that is not the curve. That is the Bezier polynomial, characteristic polynomial. And curve with the black color one is showing you the curve, Bezier curve, which passes through the first and last point and all other point in between acting as a control point. And curve always this curve is also always tangent to the first and the last polygon segment, last arm of the polygon segment. Now the degree of this equation, because ultimately it is the function of the u, the polynomial function of u. So in this polynomial u, what will be the highest degree of u? In case of a cubic spline curve, highest degree was 3, but in case of a Bezier curve, the degree of Bezier curve, that means degree of u, is related to the number of data points. If n plus 1 data points is there, it will define the nth degree Bezier curve. So that means in order to design nth degree Bezier curve, you need n plus 1 numbers of data point. That means if you have a 4 data point, your curve degree of the curve will be 3, or in order to design the cubic Bezier curve you need 4 data. If you like to design a Bezier curve with a degree is 4, then you need 5 data points, so and so on. So that means the degree of the Bezier curve depends on the number of data points, that it vary, and as it is depends on the number of data points. If you anytime if you increase the data point, your degree will change. Ultimately, curve shape will drastically change. So that is the one problem in the Bezier curve. Use of Bezier curve is if your data point will increase or decrease, your degree of the curve will change. Curve shape is drastically changed. So this is the equation. I like to skip this equation. It is a Bezier equation based on the Bernstein polynomial. So if those were CAD developer, for them it is useful. A user, for them all this equation is not required. So major difference between the Bezier curve and the cubic spline curve is, as you already mentioned, the degree of Bezier curve is variable and it depends on the number of data points. But n plus 1 data points will give the nth degree Bezier curve, whereas the cubic spline degree is always 3. Shape of the Bezier curve is controlled by its data point only. First derivative are used to curve development, as in case of Hermite cubic spline. Bezier curve is smoother than the cubic spline because it has a higher order derivative. But Bezier curve is a single curve controlled by all control points. As a result, with an increase in number of control points, degree of polynomial representing the curve increases, and this provides for the global modification effect rather than the local. But as it is the global modification because of the increase or decrease of the data points, so it has some problem, and that can be reduced, that complexity can be reduced if you can broken down the curve with a number of segment, so you can control locally. But another way you can do, you can, instead of Bezier curve, you can use the B-spline curve. What the B-spline curve is a single piece of parametric polynomial curve through any number of control points with the degree of polynomial is selected by designer. Meaning is, even if you can add control points without changing degree, it is possible because degree is specified by degree of the polynomial equation. That means the degree of q is specified by the designer. So B-spline exhibit a local control over the curve shape. Wherever a single vertex is moved, only those vertices around that will be affected, while rest remains same. So, B-spline curve which can be designed by two way, both interpolation techniques as well as the approximate techniques. Interpolate a given set of data point. It is useful in displaying the design and engineering analysis results such as stress and displacement distribution. For that, B-spline curve is used. An approximate method, it is useful for the free-form surface development, aesthetically beautiful surface development. The B-spline curve with the approximation technique is used. So in contrast to the Bezier curve, the theory of B-spline curve separates the degree of the resulting curve from the number of given control point. 4 control point can always produce a cubic Bezier curve, but 4 control point always produce, in case of a 4 control point, if you use to design a cubic Bezier curve, its degree will be always 3, and that will be cubic Bezier curve. But using the 4 control point, you can design different types of B-spline curve. It may be degree may be linear, quadratic, or the cubic. So that is the beauty of the B-spline curve. Whatever may be your control points, but degree of the curve is user defined. So equation I like to skip here. There is another concept called the knobs. Most of the CAD tools now use this generalized concept of knobs. Knobs means non-uniform rational B-spline, it is the generalization of the all curve and surface theories. And it is almost exclusively used by the modern CAD/CAM-C system to provide a unified approach to formulate and to represent the curve and the surfaces. And this is basically a algebraic ratio of the two polynomial, while a non-rational curve is defined by one polynomial that has been shown here. The main thing is using a particular generalized equation by changing the different constant parameters, you can represent the same curve can be used for cubic spline, Bezier, B-spline, only by changing the different constant in these two ratio of polynomial. So that is basically generalization of the all curve equation. A single equation, by changing its constant value, you can design either cubic spline, or you can represent either cubic spline, Bezier, or B-spline. So advantage, nerve can be considered as a unified representation that can be defined both synthetic curve as well as analytical curves and surfaces. Any curve can be formulated using the nerve concept. It can be represent all curve surfaces, curve and the surfaces and solid entities, and allowing unification and the conversion from one CAD system to another by exchange standard. And it is related to stable algorithm, and it is accurate, and the unified representation also have advantage of reducing the database complexity and number of procedures required in CAD system for display and manipulation. So it is the internal things, and but thing is, most of the CAD or all CAD developer use this particular concept of the knobs. There are some curve manipulation that when you can develop any solid model using any CAD tools. These are the curve manipulation you can do. You can displaying, you can do blending, segmentation, trimming, intersection, transformation, and evaluation of point on the curve. So a transformation, there are different type of geometric transformation like translation, rotation, scaling, and mirror. So this thing, it's a trimming, when it truncate the extra portion, you can find out the intersection, you can do a translation, rotation, scaling, mirror. So these are the some curve manipulation. Similarly, the wireframe entities, there are the different surface entities like analytical surface entities, the plane surface, ruled or lofted surface, surface of revolution, tabulated or cylindrical surface. There are the different synthetic surface, where in order to generate the synthetic surface, the starting point is the synthetic curve, and based on the name of the synthetic curve, the synthetic surface are called bicubic, Hermite cubic spline surface, B-spline surface, Bezier surface, cone surface. So curve segment is the fundamental building block for the curve entities, where the surface patch is the fundamental building block for the surfaces. So these are the some example of the plane surfaces. It is a very simple way. You can create the plane surface, you can draw a line, extrude that one, you will get the plane surfaces. There are some ruled surfaces, the surface constructed by transitioning between the two or more curves by using the linear bending between each section of the surface. So this is the example of ruled surface. There are the lofted surface. So it basically the surface constructed by the transitioning between the two or more curve by a smooth and higher order blending between each section of the surface. So next one is the surface of revolution. Axis symmetry object can be created by the surface of revolution. So you draw the 50% of your curve segment of the surface, and you rotate it with respect to an axis of rotation. You will get the axis symmetry surface. So example I have shown here. So there is the tabulated cylindrical surface. In surface modeling, these are the different types of commonly used surfaces. Other than that, using the different synthetic curve, you can design the different synthetic surface. So similar to the curve manipulation, there is the surface manipulation like displaying, blending, segmentation, trimming, intersection, transformation, projection, and so on. Now we'll come to the our main part, that is the solid modeling. So the solid modeling, as you know, that it is the more unambiguous complete representation of an object. So we now all are using the solid modeling techniques because of its completeness and unambiguity. And in this case, the during solid modeling process, CAD database stores both the geometry and topological information, and because of that, it will more complete and unambiguous representation of your object. Now, what do you mean by the geometry and topology? With a simple example, I like to show what are the geometrical information and which one is the topological information in respect to the CAD database. Geometrical information of the object is basically the actual dimension of its entity. Topological information means the topology of an object defined as the connectivity and associativity of the entities, and it determines the rational information between the entities. So geometry is visible, but topology is considered a non-graphical relational information that is stored into the solid model database, and it is not visible to the users. Now, with the simple example, I like to tell you what do you mean by geometry. If you see the left hand side figure, top and bottom figure, here you just see all the dimension like L11, the and L12 is equal, L21 and L22 is equal, L31 and L32 is equal, radius R11 and R12 are equal. An angle between these also 90 degree. But how it is different? Geometrically both are same, but topologically is different because the point for the top one, the point P lies outside the object, and the bottom case it is inside the object. So what are topological information here? L11 will share the vertices with the L21, this side C1. L21 is basically a line which share the vertices with L11 on side, other side L31 and so on. But all are same, but there are one is different, that lies outside in the first case, and P point, that the center point of the that particular semicircle is second case, it is inside the geometry. So this will create look wise different. So that is why I geometry different two object shape, and right hand side figure geometry. One is the example of examples, second set of examples in geometry. So in form modeling, modern CAD system offer two approaches to create the solid model. One is the primitive based approach, another one is your feature based approach. In primitive based approach, it allows designer to use predefined shapes like primitives as building block to model solid object. It is similar to your, say, if you like to model, or if you like to build your house, your building block is the bricks, small brick, you just add it by mortar. So that is cement, sand, water mixture, the mortar, using that you can join brick one after another, and you will get the very complex your room. Similarly, in solid object also, if there is a building block shape, that is called the primitives. It may be rectangular block, conic section, cylinder, sphere, and so on. So you just block, add one after another to get a complex solid object. Or in the reverse way, you can think a complex solid object can be a combination of different small known blocks. Now, how will you add? In bricks are added by means of mortar, but in this case, addition means mathematical operation called Boolean operation. Using Boolean operation, you have to combine the primitives to create the complex object. But because of its restricted shape in primitives, primitive approach is less used, but some cases primitive approach is also useful. Most of the times we are using the feature-based approach. In feature-based approach, because it's more flexible, as they allow the construction of the more complex solid than the primitives offer. Now, what is feature-based approach? In feature-based approach, there is a term called feature. Feature is defined as the geometric shape, that is the feature profile or the 2D scale, and the feature operation to build the parts. That means feature consists of feature profile, or that means the 2D sketch and the feature operation. What you have to do? So feature based approach, important thing is feature. Feature is a combination of the feature profile, that means 2D sketch, and the feature operation. Now profile, feature profile, here the sketch you have to draw, then you have to use the feature operation. Feature operation is the process which convert the 2D sketch into the 3D object. So, nutshell, feature is consist of feature profile, that means sketch, and the feature operation. The entities required for the feature profile is the sketch, wireframe, and surface entity. That means, in order to create the solid object, you have to start with the wireframe entities to create the feature profile. So that is why wireframe modeling and surface modeling is the most fundamental, more core thing of any solid modeling software. So without wireframe entities, without surface entities, you cannot build any solid model, because you have to first create the feature profile, that is the sketch, and for that wireframe and surface entities required. Next, the feature operation, it is an activity that converts the sketch into the 3D operation. There are different feature operation that you know, that extrude, rotate. So these are the some feature operation. Now, if in the feature-based approach, there are a lot of constraints has been used. Whatever I have shown on the screen, it is based on your CATIA software. So there are the constraints, there are the different geometric constraints as well as the dimensional constant. Geometric constraints are, so let us say this is the distance. Hello? So these are the constant, rather geometric constant. So fixed, coincidence, concentricity, tangency, parallelism, perpendicular, horizontal, vertical, midpoint, equidistant point. These are the some geometric constant which basically position the object. There are the any geometry, there are certain sites that the dimensional constant you have to apply. So geometric constant is defined as geometric condition that relates to or more scales. Next is the feature operation. Common feature operation, as you know, for the solid modeling tools is the extrude to develop the protruded feature. There will be a revolve, there is a sweep, there will be loft, there is the reef, there is the pocket, hole, slot, and the shell. So these are the feature operation commonly used. Many other feature operation is there, and the icon I have shown in respect of the CATIA software. But this kind of feature is all available for any other CAD tools like SolidWorks, NX, Creo, everywhere. These are the common feature operation. Extrude to create the protruded feature. Axisymmetry object can be created by all. Similarly, sweep, loft, reef, pocket, hole, slot, shell. So these are the different feature operation which convert 2D scales into the 3D object. Many other feature operation like fillet, chamfer, there are the different types of pattern, rectangular pattern, circular pattern, there are the different type of transformation like translation, rotation, scaling, mirror, and there will be a threading. Now the way we are doing the solid model in any CAD software, that is called is the constant based feature operation, constant based feature modeling. Because first, as you know, the CAD software, first you have to select the sketch plane, then over the sketch plane you draw the feature profile, that means 2D profile, then you apply the proper geometric constraint as well as the dimensional constraint. Once it is fully constrained, then you exit from the workbench and you just go to the part design workbench, say, and apply the feature operation to convert 2D sketch into the 3D, and you will create the base feature, and over the base feature again you select the sketch plane and you draw the another feature profile, and you can same process. You can apply the geometric constant, dimensional constant, and you get the second feature over that particular object. That means a object is consist of number of features. A particular solid object is consist of number of features. First, the base feature you have to create. Over that, you can create the multiple features, and combine a feature will build the part. So this is the basically steps in the constant based feature modeling, and most of the CAD software based on this concept, constant based feature modeling, and step is more or less same. So that I already explained. So I like to skip it. It is basically related to your software. I think all of you know that particular software, how to create the solid object by using this particular feature operation like extrude, because you know the extrude command is used to create the solid object by extruding a given closed profile. It requires a closed profile, that means sketch of the cross section of the object, and the extrusion vector you have to specify, and the extrusion direction is always perpendicular to the sketch plane, and using this is the main point in the extruded feature or extruded feature operation. Revolve command is used to create an axis symmetry object by revolving the selected geometry about and axis. It requires a profile sketch of the cross section of a solid object, and that you have seen already. The revolution vector, that means axis as an angular revolution to specify. Axis of revolution is always in the sketch plane of the profile. Same way, there is a sweep feature. It is generalization of the extrusion. It creates the feature by moving the sketch. It may be closed or open along a linear path or the non-linear path. That is called the guide curve, which is not necessarily perpendicular to the sketch plane. Lofted feature is also known as multi-section solid. Use the blend of multiple cross-section or two, that means two or more cross-section along a either linear or non-linear guide curve to create the solid object. Their whole feature, it is subtracting the material and cylindrical in shape. There are the different types of hole feature like simple or the taper hole, counterbore hole, countersunk hole. So that feature or the threaded hole is available in the most of the tools or most of the CAD software. The slot feature is again remove the material from the solid. It may be rectangular slot, T slot, and octal slot. Shell feature is used to create the hollow or thin wall solid by removing the material out. And there is a reef feature. It is a special kind of extruded feature. Create the extension of the geometry creating by creating a feature connected the two faces of the part. The input to create the reef is a contour or a thickness. There are the different pattern feature they use. Rectangular pattern they used to create the multiple copy of given feature in rectangular array. Circular pattern is used to create the multiple copy of given feature in a circular array. So if you can like to create same object multiple numbers, if it is arranged in a rectangular fashion, you can use the rectangular array or rectangular pattern. If it is over the circumference of the circle, then you can use the circular pattern or circular array. It's a different software with different name. So fillet are used for smoothing the sharp edges of the solid. The input to create the constant radius fillet feature is to select the edges to be fillet and fillet radius. Chamfer is used to remove the sharp edges for the part, and input to create a chamfer is the angle distance or the distance. So like that, in case of fillet, you put the radius and the edge, select the edge, and you just specify the radius. But in case of chamfer, you select the edge and you have to tell the angle and distance or distance in the two legs of the chamfer, and it will do. Now there are the different scheme in the solid modeling techniques. It is software again point of view, boundary representation modeling, boundary representation or constructive solid geometry. Other thing is obsolete nowadays. These two method or these two solid representation scheme is used by the most of the modern CAD software. One is the boundary representation, that is called BREF. This is the philosophy, or this is the technique by which the solid object can be represented. One is the boundary representation, another is the constructive solid geometry, that means CSG. Now, in the boundary representation concept, it is basically a topological notation that an object is bounded by a set of faces. As you know, the faces are closed, orientable, and bounded by the edges. Each faces is bounded by the edges. Again, each edges is bounded by the vertices. So ultimately, a fundamental thing will be your points, then the lines. So B-rape or the boundary representation of an object consists of the faces, edges, and vertices. That means points. So all this information will be stored into the CAD database. If you see the specification tree of any CAD database, you can see it is used boundary representation, and in the history, it will store all the things like points, lines, faces. All the data will be stored in the CAD database, and it will also show in the history or the specification tree of any CAD tools. Now, what are the advantage of the boundary representation? Boundary representation is very appropriate to construct the solid model of an unusual or the complex shape like turbine blade, auto bodies that are difficult to build using the primitives, and it is relatively simple uh, to convert the boundary representation model into a wireframe model, because the model boundary definition is similar to that of wireframe
Hello.
definitions.
May I
Hello?
interrupt, sir? May I interrupt?
Tell me.
Yes, sir.
Uh,
Because the meeting will be closed after 2 minutes, sir. Because the time limitation is
uh,
showing here, sir. So we have to
okay, okay.
rejoin again. Okay, sir, with the same link. And
Sure, sure.
all the participants, I request you to rejoin this meeting after 2 minutes. If automatically this was disconnected. Okay. So after that you rejoin this session again. Okay, sir. Okay.
Okay,
Thank you, sir.
okay.
Thank you, sir.
So disadvantage of boundary representation is it requires a large amount of storage, but nowadays storage is not that issues. Next, representation is a constructive solid geometry. This is also parallelly used, or it is in addition to the boundary representation. CSG topological notation is also used in the modern CAD tools. CSG model is based on the topological notation that a physical object can be divided into set of primitives that I already mentioned, that the basic element or the shape that can be combined by certain order by using some rules, that is the Boolean operation, to form the object. Primitives are considered as a building block. Primitives are a simple basic shape, and it is combined by the mathematical Boolean operations and to create the complex solid object. Primitives are block, cylinder, cones, sphere, wedges. So these are the some primitives, and combining these by using the mathematical Boolean operation, you can create complex solid object. Now, what are the different Boolean operation in CAD, like union, intersection, and difference? The union combines the two primitives, like here your cuboid and the sphere has been combined, and you will get this shape. Right hand side equal, after equal sign is shown the shape. Intersection is the intersection of the two primitives give you the shape equal to their common value. You see these two intersection will be like this one. Difference, use the subtract one primitive from other and result in a shape equal to the difference in their volume. So this is your difference. That means one has to be subtract. That means the sphere has been subtract from that cuboid. So this using like last one, it is very difficult by using the feature approach, but using the your primitive approach, you can easily create this one. A very simple two primitives, you do the Boolean operation difference, and you can easily create this one. So that is why sometimes primitive and Boolean operation based approach is also used. So it is a combination of both feature based approach as well as the your primitive based approach. So most all CAD software nowadays is the combine of these two. Whatever, you have to take advantage of both the method or both the approach. So this is another example of this one. Now, advantage of the CSG, it is easy to construct out of the primitives and Boolean operation. It is concise and requires minimum storage. And disadvantage, the major disadvantage of CSG is its inability to represent the sculpture surface or the non-analytical surface, and cannot be modeled using the CSG scheme. And modern, I already mentioned, modern CAD provides both approaches to increase their modeling domain. Now, once you develop the solid model that I mentioned here, that it can be used in the different downstream applications. So the solid model or the geometric model you have created by the geometric modeling tools, it can be used in the different downstream application, and it is first is the using solid model you can do the assembly design. You can make a mechanism. You can do the drafting based on the solid model. If automatic drafting is possible. Then solid model based mechanism analysis and simulation. Any mechanism, kinematic and